Alright, welcome back. Today we're going to work our way through section 2.4 where we start putting our knowledge of trig functions and degree measures together with solving right triangles. Now when we solve a triangle, that means we are finding all the information about the triangle. Triangle has 3 sides and 3 angles, and by the time we have solved that triangle, we're going to know the values, the measures for all of that. Now, as we start solving, we want to be concerned with the difference between exact numbers and theoretical numbers and significant digits. An exact number is the result of counting. For example, I can tell you exactly how many pens I have laying next to me because they are distinct and I can count them. I don't have to measure. Theoretical numbers are the results of measurements. Because no matter how carefully I measure, my measurement is going to be inexact. If I measure this pen in inches, it's not going to be nearly as exact as if I measured it in centimeters, which isn't going to be as exact as if I measured it in millimeters, and I can work my way down. If I got out a laser measuring tool, I could be more exact, but I'm still going to have a measure of error. And how exact needs to be depends on the circumstance, right? If I'm building a house, I need the walls to be square enough that they're going to stay up. If I'm doing brain surgery, I need to be way more exact. But anytime I'm given a measurement, that's a theoretical number because I can't be as exact as I would be able to if I had a different measurement tool. Okay. Significant digits are digits obtained by actual measurement. And the importance of significant digits is that my answer can't be more exact than the least exact measure. So I want to, right there, that's what that one says. The answer is no more accurate than the least accurate number in the calculation. So let's talk about what significant digits look like. If I'm measuring an angle to the nearest degree, for example, both of these values have 2 significant digits. 62, 36, each have 2 significant digits. If I go to the nearest 10 minutes or the nearest tenth of a degree, both of these values have 3 significant digits. Notice that I'm not counting that trailing 0 here for the 30. We assume that I've rounded that off to the nearest 10 minutes. To the nearest minute or the nearest hundredth of a degree, both of these answers have 4 significant digits. If I go to the nearest 10 seconds or the nearest thousandth of a degree, both of these measures have 5 significant digits. Again, notice that we're not counting that trailing 0, we're assuming we have rounded off. Now, significant digits can get a little weird. Let's say that I had the value 800, and that's my measurement is 800. Well, that's just one significant digit, even though that 8 is here because it's followed by zeros. So just kind of keep that in mind. We're going to work to be precise with our number of significant digits. Occasionally there's a case that gets a little questionable, but usually it's pretty straightforward. In general, remember that we are going to count the zeros after a decimal, but not at the end of a whole number. You can count the zeros after a decimal, but not at the end of a whole number. So, for example, 18.00, that counts as 4 significant digits because the only reason to have zeros after a decimal would be to use them for significant digits. If I have 1,800, that only gives me 2 significant digits, and I should have abbreviated that as significant digits. This looks like standard deviation. Let's change that to significant digits. Okay, let's look at that next page. So here we're going to solve our first right triangle. You've got to always start with a sketch. Now, when we start with a sketch, we don't have to worry about if our angles are all accurately represented. We're doing a right triangle, so I'm going to sketch a triangle that appears to have a right angle. And we're always going to name that right angle C. So wherever you start labeling your vertices, we want to, by just our general agreement of standards, we're going to put C at the right angle. I'm given some information. I'm given that B is 28 degrees 40 minutes, so B is 28 degrees 40 minutes, and that side A is 25.3 centimeters. Side A is opposite angle A, so that's going to be over here, 25.3 centimeters. Those are my givens. Those are the things I know. I know two angles and I know one side. To solve a triangle, I need to come up with the missing values. I'm missing one angle and two sides. So I'm missing angle A, and that's actually going to be my easiest place to start, because I know that the sum of the angles in a triangle is 180, and I know that angle C is 90 degrees. That means that angles A and B have to sum to the other 90 degrees in my triangle. So angle A is going to be 90 degrees minus 28 degrees 40 minutes. Now notice that I set this up stacked so that I can think about what I'm subtracting from here. I'm going to have to borrow a degree, make that 89 degrees, and when I borrow a degree, that degree is 60 minutes, so that I have something to subtract my 40 minutes from. So there's 20 minutes, and 89 minus 28 is 71 degrees. 61 degrees. It's early here while I'm recording this. My angle is 61 degrees 20 minutes. So that's the value, the measure for angle A. 61 degrees 20 minutes. Now, as I take a look at this, there are some things that I notice. For example, C is my hypotenuse, so side C is going to be the longest side because this is my largest angle. Side B is going to be my shortest side because it is opposite my smallest angle. Now remember, we said that our triangle doesn't have to be drawn to scale. We just know that we've got a right triangle, we've got a sketch, so we can pair up our measurements successfully. Now, you always want to use your givens if you can. So you want to use our given values if possible. Use your givens if possible. What am I given? I'm given this angle and I'm given this side. I need to find both of these. This side is adjacent to angle B. So let's start with tangent. We need to find two sides, B and C. If we start with tangent of angle B, tangent of 28 degrees 40 minutes, tangent is opposite over adjacent. So I can say that is equal to B over 25.3 centimeters. And then I can solve for B. I'm going to solve for B by just multiplying both sides by that denominator, 25.3. And that's going to give me my value, my length for side B. Now, in my measurements that I was given, I have 3 significant digits, so 3 significant digits are what I'm going to keep for my answer. I'm going to use 3 significant digits. And in my calculator, make sure I'm in degree mode because that's what my angle is, it's in degrees. I'm going to do 25.3 times the tangent of 28 degrees and 40 minutes. Remember, that's 40 out of 60 minutes that makes up a degree. I can type that in as 40 out of 60. 40 out of 60, I could do 4 over 6 because if I simplify that, it's 4 over 6, or I could do 2/3. Totally up to you how you want to plug that into your calculator. But there is the length of side B. Remember, we're keeping 3 significant digits, so I write that down as 13.8 centimeters are the units that I'm in. So don't forget to include your units. Okay, so we found side B. We found all our angles first. We found side B. Let's find side C. Side C is hypotenuse. If I use my givens, go back to the idea that I'm just going to use my givens, I've got adjacent, and over hypotenuse would be cosine. So I'll use cosine of 28 degrees 40 minutes, and that's equal to adjacent over hypotenuse. Now this time I got to rearrange a little bit more. As I start rearranging my terms, I'm going to solve. I need to solve for C. I'll multiply both sides by C, and then I'm going to need to divide out this cosine, so that I've got C times cosine of 28 degrees 40 minutes is equal to 25.3. I'm going to divide both sides by that cosine. Right? So now I've set it up to solve for C, and this is what I'm plugging into my calculator. When you plug that into your calculator, 25.3 divided by cosine of 28, and remember that 40 minutes is 2/3, so 28 plus 2/3 of a degree. I get out, this is my side length for C. We're keeping 3 significant digits, so we've got 28.8 centimeters. And then I'm going to stop for a second. I'm going to go, okay, so C is my longest side. Yep. B is my shortest side. Yep, that works. Looks good. Okay, so to maintain accuracy, there's my reminder again. To maintain accuracy, always use the given information as much as possible. Don't round in the intermediate steps. Avoid rounding until you're done. All right, let's do another. And then we're going to move on to talking about angles of elevation and angles of depression. Solve right triangle ABC. Set up our right triangle. C is going to be our right angle, always, always, always. A and B, negligible, it doesn't matter where you put those, just make sure that you label your triangle accurately. This time, instead of being given a second angle, I'm given 2 side lengths. Side A is 44.25. Side A is opposite angle A. Side B is 55.87. Side B is opposite angle B. And I know that C is going to be longer than either one of these because this is my right angle, so that's going to be my longest side opposite that largest angle. And I know that angle B is going to be larger than angle A because side B is longer than side A. These are things that I know. Now, because I don't have a second angle, I'm not going to start with my angles. I'm going to start by finding this missing side. My missing side is the hypotenuse. I fall back to my Pythagorean theorem, a squared plus b squared equals c squared. So C is going to be equal to the square root of the sum of those squares. Now, order of operations, you've got to make sure that you use your calculator well. You want to add up the sum of those squares first and then take the square root. However that needs to look, whatever that needs to look like to you to get it accurately done. There is the sum of my squares, and then I'm going to use that second, and find the square root, and then I'm going to use my second answer combination so that I don't round that off, and I get that this is the length of side C. Now, how many significant digits am I keeping here? I'm keeping 4 significant digits for this problem because that's what I was given for my measurements. So C is 71.27 centimeters, which works for me because that's the longest side. And now I can use my information to find my missing angle measures. In the spirit of not using a found value, always using the given values. When I go in and I find these angles, let's start with B. If I find B, the sides I was given are the opposite and adjacent sides. That's tangent. So this was my first step. My second step is going to find B using tangent, opposite over adjacent sides. That's my value for tangent, which means I know the value, I'm looking for the angle. So angle B is going to be the tangent inverse of that tangent function value. So I'm going to be using my calculator again. When I do tangent inverse, I'm in degree mode, so we're in good shape. There's my degree mode on my screen. Tangent inverse, second function tangent, plugging in opposite over adjacent. And this is the value I get for my angle, 51.62 degrees for angle B. B is about 51.62 degrees. If I wanted to change that to degrees and minutes instead of decimal degrees, it would be 51 degrees, and then I would take this decimal, 0.62, and multiply it times 60, and that gets me to minutes. So it would be 51 degrees, 37 minutes, and I would have to round it to that 37 because that is my 4 significant digits. Alright, and then my third missing piece is angle C. No, angle A. Angle A. We're going to use tangent again because that uses just my given information. Tangent of A is the reciprocal of the tangent of B. It would be the cotangent of B. So angle A is going to be tangent inverse of that value. Remember, opposite and adjacent are the other orientation. So when I plug that into my calculator and I do tangent inverse, I get out 37 point, and we got to round it to 38. Angle A is 38.38. Sorry, 38.38 degrees. If I wanted to do degrees and minutes, I would take that point. And you know what? I'm gonna keep it 0.3798. 0.3798 times 60, and it gives me 23 minutes. Rounding to 4 significant digits is rounding to the nearest minute. Alright, and that's how we solve a triangle. When you start with a triangle, you're going to start with 3 pieces of information. To solve it, you find the missing 3 pieces of information. Okay, let's look at angles of elevation or depression. When we're applying right triangles, the angle of elevation from point X to point Y, where Y is above X, so we're moving up, elevation, is the acute angle formed by that ray in a horizontal with the endpoint at X. So it's from a horizontal up is an angle of elevation. From some horizontal ray up is an angle of elevation. If I'm moving from the horizontal down, that's an angle of depression. So up is elevation, down is depression, and it's always from that horizontal. So from some line of sight where I'm measuring my angle of elevation or angle of depression. Whenever you're solving an applied trig problem, whether it's this type of problem or another type of problem, you are always going to start by drawing a sketch. Don't skip this step. It really is necessary. It helps you verify your information and ask yourself whether or not your answer you get makes sense. Make sure you label the quantities that you're given and label them accurately. You're going to use the sketch to help you write the equation. It helps you see what you know and what you need to know. And then you solve that equation, right? And finally, make sure you check to make sure your answer makes sense. Okay, finding a length given an angle of elevation. The angle of elevation from a point on the ground, 15.5 meters from the base of a tree to the top of the tree is 60.4 degrees, and we need to find the height of the tree. So we've got a tree again. I do not draw pretty trees, doesn't matter, right? We have some type of measuring device out here on the ground, so that's my horizontal, and the angle of elevation to the top of the tree, we have some kind of a laser pointer. You see guys out measuring on the roads, doing their surveying. Sorry, that's not straight. I really need to get a straight something to do a straight line here. But if I'm going from that horizontal up to the top of the tree, that is 64 degrees. That is my angle of elevation. Now, this point on the ground is 15.5 meters from the base of the tree, and I have formed a right triangle, assuming my tree is growing straight up. I'm measuring to some point up, straight up. What I'm looking for is the height of the tree. I'm looking for this value here. We'll just call it x. So I don't need to solve the triangle, I just need to find this value. Well, I know this angle and this side is adjacent to my angle. The side I don't know, the side I need is opposite. Opposite over adjacent is tangent. So I'm going to use tangent of 60.4 degrees, opposite over adjacent. And that's going to give me the height of my tree. Why wouldn't I do adjacent over opposite? Well, because I don't have a button for cotangent, it's more work. If I stick with my 3 main trig functions, then I can very straightforwardly just use my calculator to solve. Okay, so to solve for x, I'm going to multiply both sides by this 15.5. And when I plug this into my calculator, how many significant digits? It looks like I've got 3 significant digits I need to keep here. So I've got 15.5 times the tangent of 60.4 degrees, and I'm in degree mode. Comes out to 3 significant digits. I've got 27.3, and my units are meters. The units are part of your answer. Don't forget to include the units as part of your answer. Alright, let's do a few more of these elevation and depression problems. When Sue is standing 123 feet from the flagpole, the angle of elevation to the top of the pole is 26 degrees 40 minutes. Her eyes are 5.3 feet above the ground. So from her line of sight, that is our angle of elevation. She's looking up to the top of the flagpole. Let's get our sketch drawn here. We've got a flagpole. Sue is standing out here somewhere. And our angle of elevation is from her line of sight, not from the ground. So there's my horizontal, and my horizontal is at 5.3 feet up from the ground. And then I've got my angle of elevation. I'm getting smart, guys. Angle of elevation to the top of the flagpole from her line of sight is 26 degrees 40 minutes. 26 degrees 40 minutes, not 26.4 degrees. 26 degrees 40 minutes. And we want to figure out the height of the flagpole. But keep in mind that we are measuring from a point 5.3 feet off the ground. So when we get this value x is going to be this side that is opposite my angle of elevation. I'm going to have to come back in and add that 5.3 feet on at the end, because that's from her line of sight, from her horizontal. Okay, how far away is she? She is 123 feet from the pole. This is that 123 feet. So again, I'm using tangent, my tangent of my angle of elevation. So tangent of 26 degrees 40 feet is going to be opposite over adjacent. I'm in feet, so that's important. X is going to be 123 times the tangent of 26. And remember that we already simplified 40 over 60. That simplifies down to 2/3. So 26 plus 2/3 degree. I am not rounding that off. Remember, we're not going to round in the intermediate steps. We do not round here. We do not round here. We don't make that 26.6 degrees, because that's going to give us an invalid answer. So when I plug that into my calculator, I've got 26 plus 2/3 of a degree. And that gets me to 61.77. How many significant digits am I interested in? Well, I'm interested in 3 significant digits because we kept that trailing 0 to keep it at 3 significant digits, 3 significant digits, 3 significant digits. I'm going to keep an extra one here just to make sure. 61.77. So that X is 61.77 feet, but that is not the height of the flagpole. When I go back and I verify with my sketch, I say, oh yeah, I got to add on 5.3. So that gets me to 67.07. I'm really glad I kept that extra decimal place. 67.1 feet is the height of the flagpole to 3 significant digits. It's important not to round in intermediate steps. It's important to keep an extra digit at least until you're done so that you know you've got the right answer. Okay, angles of depression. We've got 2 examples of angles of depression and then we're done for this section. Find the angle of depression from the top of a 97-foot building to the base of a building across the street. Alright, so we've got 2 buildings across the street from each other, and we don't care how tall they are in relation to each other. We know that this building that we're measuring from the top of is 97 feet tall. This building is 42 feet away. And we are measuring from the top of this building to the base of the building over there. So there's my measurement. I'm going from the top of one building to the base of the other. Now the horizontal is from the top of this building, right? That's my horizontal. Here's my angle of depression right here. We are looking for the angle of depression this time. We don't know it. So I'm going to label the angle of depression as alpha. This is my value, my Greek letter alpha. This is my angle of depression. Now notice that I've got everything labeled down here. I've got this angle of depression. Do you remember our special angle pairs? 2 parallel lines cut by a transversal. These are alternate interior angles. You are absolutely welcome to work with what you've got just like it is, but I want to point out to you that if this is alpha, this is also alpha, because these are alternate interior angles. They have the same values. So I always flip my angle of depression down here because I've just labeled this right triangle, and it makes more sense to me. My angle of depression, this alpha is the same as this one. Opposite over adjacent, I'm using tangent again, but this time I don't know the angle. Opposite over adjacent, I don't know the angle. I'm solving for the angle. Since I'm solving for the angle, I need an inverse function. My angle is going to be that tangent inverse of this tangent value. When I look at my measurements, I've only kept 2 significant digits here, so I only keep 2 significant digits in my answer. You should get out an answer of about 67 degrees in your calculator. Make sure you use degrees so you're not saying radians. Okay, one final example here. I want you to pause the video, take a second, and try to draw a sketch on your own, get it labeled before you check back in to make sure that your answer matches mine. So we've got a cliff, we've got a lighthouse offshore. The lighthouse is 430 feet away from the base of the cliff. We've got the angle of depression from the top of the cliff. So there's my horizontal to the base of the lighthouse. So there's my angle of depression. Right there's my angle of depression from the horizontal down. Label it theta just for variety's sake. I know that this angle theta is the same as this angle theta because they are alternate interior angles, alternate sides of the transversal between 2 parallel lines. so that the tangent of theta is going to be 210 over 430. And to find the angle, I'm going to use my inverse function. Plug in the tangent function value to solve for the angle. How many significant digits do I have? Well, there's no decimal, so the zeros don't count. I've only got 2 significant digits. So you should end up with a theta function or a theta value, an angle of about 26 degrees. Let's go ahead and verify that. Tangent inverse, I'm in degrees. 210 divided by 430. Yep, there we go. 26 degrees. Alright. Make sure you do a sketch, you label things carefully, and then go back to make sure that your answer makes sense.